for the next speaker standing between us and lunch. James Foster from Smalltalk Systems on Smalltalk in the cloud.
And a lot of this is going to be hands-on, so I will probably be putting the microphone down a bit when we get to those parts of it. So we're going to describe platform as a service, how you can have Smalltalk running in the cloud. And we'll see what the state of the art is now, and hope to get some feedback from you on this. We're going to discuss Cloud Foundry, kind of an overview of the particular framework that I've chosen to work with. Look at how we can run it on Amazon, then try out launching Pharaoh, and then Gemstone. The general idea of platform as a service fits into this sort of a matrix, where we start with the self-hosting, where you take care of everything yourself. You might have a data center, and they look after power, air conditioning, the network. You might get infrastructure as a service, where someone else provides the CPU, RAM, disk, so that would be the Amazon situation. We're particularly thinking of how can we as programmers take advantage of something that would be platform as a service, where someone provides the operating system, web server, runtime framework, and all you need to add is the application, which is the part that we as the programmers do. With Cloud Foundry, what we can do is push an application, and when you type this or use some tools to push your application to the web, it will then end up on the server, where there's a load balancer routing that takes the web requests and sends them on to your application. If you need to scale things, you just say, oh, I want 3 instances instead of 1. And then the router or load balancer will distribute things among that. One sample architecture would be to have this machine with this IP address acting as the router, a firewall proxy server. Then it would send the request here, where there'd be another thing that would distribute it among the various applications. And in this example, we were looking at Ruby. There's other parts of the Cloud Foundry framework that build on top of that. Cloud Foundry has good support for Ruby, not surprisingly, given its popularity. Ruby, as most of you know, is an interpreter that works with text files, where the application code then includes external libraries, and there's frameworks like Rails and Sinatra that can be preloaded on the server. Another thing that is done with Cloud Foundry and many of these others is good support for Java. There again, you have a runtime virtual machine interpreter compiler that works with jar files. The application code includes external libraries, and the frameworks can be pre-built. As most of us know, Smalltalk is a bit different in this regard. We don't have broken up little components that we can send off to someone else and say, include all these other things. We tend to build a big monolithic image. We don't tend to work in text files. Now we could, that's one of the ways we could approach this, is work with text files, send the text files up, have the image built remotely. The alternative is just push the whole image. So Cloud Foundry, cloudfoundry.com is a commercial hosting provided by Pivotal, which is the child of VMware, EMC, and GE. Cloudfoundry.org is an open source platform as a service framework that is used by cloudfoundry.com as well as a number of other providers. So many of the commercial hosting services will be using Cloud Foundry. And it's open source, so we can use it as well. Now, where will we put it? Let's look at Amazon a bit. Been learning a bit about that. There's, at the base, the global infrastructure. They have regions and availability zones. Regions are places around the country where they have data centers. And so they have a couple on the west coast, east coast of the States. They have one in South America. The Europe one is in Ireland. And then they have Australia and a couple others in Asia. Above the infrastructure, they have some foundation services. We will be looking particularly at Amazon EC2, at the EBS, which is the block storage, and the networking has DNS services. Then we'll be using the web interface to do some management of it. So the regions, there's various regions. When I'm working at the office or at home, I use Oregon because it's close by. And they are distributed at different locations, so you choose one that's geographically close, but there also are some differences in price. So while I've been working here, and the demo I will give you today is working with the European data center, which costs 6.5 cents US per hour, whereas when I'm running in Oregon, I'm only taking 6 cents out of Dan's pocket for each hour that I do that. Within each region, there are availability zones. So you can, and these are actually in the same region or location or city, but they're actually separate data centers connected to the high-speed link. And so you can have redundancy within a region that's in separate data centers. So, and the communication within Amazon between availability zones is very fast, and I believe it's essentially free. So if you want to transfer things from one to another. Yes?
But it still means it's available, it's reachable from everywhere in the world, right?
Oh, yes, yes, yes. I started out, I mean, because I was working in the Oregon one, when I arrived here, I just kept working on the Oregon one, and it took, you know, 80 milliseconds instead of 40 milliseconds for each round trip. And after a while, I figured, I'm coming to the European Smalltalk users group. I should give my demo saying that I'm using the European data center, and give you a chance to use it as well, and give you the best possible response time. But yes, yeah, it's just an IP address, and it's just a network hop. And they've got, you know, fairly good pipelines between North America and Europe, but it's not as good as staying in Europe. So IP addresses, Amazon has something called an elastic IP. It's elastic, but it's static. But it can move between VMs, so you can pick it up off this VM and put it on that one. And so you can associate then a domain name server with an IP, then you can associate an IP with a virtual machine. Storage, disks are it's something that they call elastic block store is one of the options, the primary one that we're looking at. Persistent disks, they provide the redundancy, they do the various backups and so on. So even if you lose the disk, they will not lose the data. These disks can be attached to one VM at a time, but can be attached, you can disassociate it from one, put it on another, just as if it were a physical disk that you took out of a rack and put in another one. You can have multiple disks per VM, so you can just say, I want to have this size. And for those of you who have configured Gemstone, you know that we like to say the extents go on one disk, the chan logs go on another disk, the swap space and operating system, and if you have more extents spread across multiple disks, you can improve performance. Now, the virtual machines themselves come in a wide variety of configurations. You can't see this, but you may be familiar, I can read off some. There's the memory one small that has 1.7 gig of memory and one CPU and relatively low network performance. An M1 medium is one CPU but twice as fast and has 3.75 gig. it is interesting when I build a Cloud Foundry system on a small, it takes about an hour and 40 minutes. Now that's not what you'd be doing, that's what I'm doing behind the scenes. And when I do the same thing on a medium, it takes an hour and 20 minutes on one and 40 minutes on the other. So, you know, we're essentially 80 minutes or 40 minutes. So they, you know, you get what you pay for. The M1 small is 6 cents a minute. The M1 medium is 12 cents a minute. But it has more than twice the RAM, so that may be valuable. Okay. I guess we're just going to speak up and you'll follow along. There's a command line programming API. There's a command line API and programming API, and then I'm using the web API. And I am running PowerPoint on the Mac, on the Windows, but I think it would be better if I ran this on the Mac. So, I'm going to go to AWS, Amazon Web Services, and say I want to get to my environment. If we go to the main top-level global environment, then we can see things like our DNS setup. And so I have cf.gemtalksystems.com is managed here at Amazon, and I can set up various records for it. I can then go to my instances, or I can go to my view of the European data center. And in this case, there are things like I do have an IP address that's associated with this data center. IP addresses are tied to a data center. You can't move them from one data center to another. But I can say this is an IP address that I've allocated, and I'm associating it with a particular machine. So what I'm going to do is say, I want to start up a new server. And I'm going to do it here. I'm going to say, we're going to call it ESUG Pharaoh demo. And I'm going to say I want to do more rather than one of the pre-built ones that they have. And here we have 11,695 virtual machines out there, one of which has Pharaoh in the name or description. Okay, so this is something, if you have an Amazon account, you can log in and just search for Pharaoh. And this is a public AMI that I have out there. Click continue, and then it's, you know, says, is there anything you want to adjust about this? And it's kind of, yeah, it shouldn't be a micro, it should be a small. And otherwise, let's see, the name, security, I want it to use the Cloud Foundry security. One of the things Amazon does is in their data center, they have a firewall, and it's your response, you can configure what traffic reaches your machine. This isn't a firewall that you manage inside your virtual machine, your Linux. It's something that sits outside. And so the traffic doesn't get to me unless I've said I want it to come through. So I've configured something called Cloud Foundry that lets in ping and HTTP and SSH. And storage, we're going to just take the default of 8 gig, but you could make it bigger if you wanted. And you could give yourself more disks if you wanted. So I'm going to save those changes and then launch. Okay, so my instance is now launching. I have a virtual machine that's spinning up there. I can do other things with it while it's launching, or I can just sit and watch it. So right now we can see there's a line here. There's a bunch of other things which try to ignore. There's one here that says empty, M1 small, pending, initialize. So this is the virtual machine that's getting spun up for us right now. Now, it says running, and it has a name. I can click on this, and I can see various pieces of information about it. This came from an Amazon machine image that was created here. It's in this location, it's this type. It has this public DNS, and it has a private DNS. So for when you're in Amazon, there's a public IP address and a private IP address. So that you're actually running your own virtual private network within it. And so I could take this IP address and go to a terminal and clear. Yes, we're doing something else here. And so now if I say ping, it says, oh, okay, your machine is out there. But of course, what we're interested in is doing something with Pharaoh. So I have in my cloud environment a download of the peer one-click. Now, we tried to get this working. It turns out that today's download of the peer one-click does not have peer in it. And I'm not sure who's worried about that, but what I've done is I've extracted out of this directory a number of files. One of them is a private key. Okay? When I log on to this virtual machine, I can use a private key. And that gets me in without having to use a password, and only someone who has this private key can log on to the machine. Its password is disabled. I have a Pharaoh image, peer image changes sources, and a couple other things that may need a little bit of explanation. When you're running on Cloud Foundry, you don't run on port 80. You need to have your own port that's assigned to you. And so, or 8080 or whatever the custom is that people are using. So instead, what I need to do is write a little bit of Smalltalk code that gets run at each launch that says, which port am I supposed to be on? Find the seaside things that are happening, stop them, assign the correct port, and start it up again. And so I have a script that allows me to test this from a command line that just says open, cog, pass it, the peer image, run this startup script, and use that port. And so if I say /test, then it starts up peer. Now this is on my local machine, just we're showing that it's possible. And then if I were to go to a web browser and say localhost, then we've got Seaside running. Okay, but we'd like to see if we can send that to the web. And so again, what we've got is this. We're not going to send the whole one-click image. What we're going to do is we're going to send the image, changes, sources, startup script. So we're just going to send those things. Now, it turns out those are non-trivial things. Before we do that, we can go look at the machine. We don't have to. And if someone else were providing this machine for you, they would be responsible for keeping it running. But just if you want to see what it looks like inside, we can ask Amazon, so if I wanted to connect to this machine, what would I do? And so we can go and we can clear. We're going to log in as the user Ubuntu on this IP address. And but first we need to be in a directory that has our private key. So cloud 2. Oh, I'm sorry. This is still logged on to another server. Exit. Okay. Now we're in an interesting place. Okay. So now if I paste this, it will say, okay, this is a new server we don't recognize. You want to connect to it? And I say yes. So it adds it to the list of known hosts, and then it sends the SSH request, and we expect to connect to it shortly. The machine, again, is a single CPU, relatively slow machine, and it's not... Ah, well, did I misspell the name? I think I may have. Okay, that went more quickly. Thank you. Okay, so we're here, we're logged in. We can see that various things are running. There's something up there called a router. We've got Ruby, Java, Postgres, whatever it is that Cloud Foundry thinks that it wants to do. It turns out we also have a directory out here called opt_pharaoh. And this has a virtual machine, it has the libs, and so on. So I've pre-installed into this Cloud Foundry system those pieces. And when we're in there, we can take a look at a few other things if we wanted to just see what the health of Cloud Foundry is. But we'll come back to that, I think. Actually, I want to get Pharaoh started. So we have this app. In order to interact with it, I need to have the correct IP address. And so I'm going to take the IP address from this, and I'm going to update my scripts and say, here's the things. And so then I have a series of commands. I'm going to, from my Pharaoh directory, say, target this Cloud Foundry system. And it says, okay, we'll do that one for you. One of the things that when you launch it, you can specify a password. If you don't specify a password, it will generate a random one for you. And this has been actually one of the more interesting challenges. When you create an Amazon machine image, it has everything in it. But one of the rules from Amazon is it can't have any default passwords. And so every launch of a new image has to create random passwords or accept ones that you give it. And I skipped that step, so it created a random one. So I'm going to take that and put it in here as my random password. So then I can log in. Sorry, wrong workspace. So I can log in. It says we'll go out to that Cloud Foundry system and we'll see if it's willing to accept that. So then there's a series of steps that Cloud Foundry supports, something called spaces, and then you set your target to a particular space, and then you map, so you can actually tell Cloud Foundry, respond to requests that came to this host name or domain. So we're there. We can see what it's expecting. So at this point, we can say let's remove the manifest so that it gives us a chance to start it over. So I'm going to say push, and it says, what do you want to name this? I'm going to name it peer. How many instances do you want? 1. How much memory does it need? I'll take the default. What subdomain do you want it to run on? Peer. What domain do you want it to run on? And this is, again, something that if I were using the DNS and Elastic IPs, I could name it something like cloud.gemtalksystems.com. You could name it, whatever you want for your application. Does it need any additional services? No. Shall we save it? Yes. Okay. Now, here is where things are likely to go a bit better for you at home than they are here during our demo. Because right now I'm getting about, 1 meg out per second. So it's going to take a few seconds to upload that. While it's doing that, we can take a look at a few other things. One is see what are the components of the Cloud Foundry system. And so there's something called Monet that has its summary, and I can go into there and say, so tell me what pieces there are. And turns out Cloud Controller Jobs isn't really needed, isn't currently being used, but they've got it in the configuration. So there's a series of components that Cloud Foundry has that are running. Start up, run, interact with each other. And so while that's happening, okay, so we're told now that we took our application, we uploaded it to the server, and it says, okay, we are running peer now at this address. So I can copy this address out, put it in my browser, and hit enter. And I am being served up pages from the cloud. Now, even though I've been looking at things behind the scenes just to see what's going on the machine, that's more of an admin role. Nothing that we did required that. All we did here was just go into our application that has a peer image in it and said CF push, and waited a few seconds, and then it said push was successful, it's up and running. So that's up there. Now, something else I'd like to look at as well is maybe being able to run Gemstone. So if we had Cloud Foundry with Gemstone, you can just say, so, you want to start up one of those? And it's kind of, yes, I'd like to. That will be, this. And I could be a little more careful here and say password and walleye instead of swordfish, and take the default disks, give it a name of ESUG2013 demo. And we're going to use the key pair so that it lets me log in. Cloud Foundry, and then launch. Now, part of the limitations here is some of you found out that you can't do, certain ports are blocked by the local university's rules. And so I'm not able to connect to the machine and run the tools that I would like to run, but if the ports were open, I could connect to it and we could just see the code there. But now that it's running, I can go in, log into it, change root to Ubuntu. And it's a new machine, so I haven't seen it before. I can't recognize it yet. One of the things that takes a few moments, and I'm running out of time here, is because we can't put anything on the Amazon image, machine image, when it launches, it has to read some of the things into it. And so even though it's running and might respond to ping, it's still sort of working itself into being available. But,
It's missing your file, no?
oh, well, that would, thank you. Okay, yes. Two.
You are on the
Oh, I'm-
machine.
Ah. So, where, oh, yes, okay. Let's try this again.
Coupon.
Thank you. So we can say yes. And so it's adding it, logging in. Now, just to kind of speed up the process, let me just show you. So there we're logged in. We can do GS list. It's got database running, NetLBI, other sorts of services. We could start up something. So for example, I have in my cloud environment, I have something called Topaz Web. And what I've done is said, I'm going to use Ruby as a way to get into Gemstone. So, for example, I can now bring up a web browser on 4, 5, 6, 7. And right now I'm running Topaz in a web browser. So here you're coming through the HTTP area, but and actually I'm able to show error output different from here. So I could say set user data curator, password swordfish, gemstone, GS64 stone, login, status, send 10 factorial, and log out. So here we're actually using a web browser to get to Topaz. And so just over the internet that way. So let's see. All of these slides so far have had the GemTalk logo on it, and they are official. This one is not official, and this is just a chance to dream, but don't hold anyone accountable for it. Wouldn't it be nice if we could offer Smalltalk in the cloud? And how would we do that? What would you like? What would you need for Pharaoh to be offered in the cloud? What would you need for Gemstone to be offered in the cloud? And particularly if you have any checkbook to back it up, then you should definitely talk to Dan and Norm about it. Otherwise, I think it's noon, and I can take questions. A lot of people have contributed to this. I think the folks at HPI have been using a cloud for submitting their Squeak assignments. So you do your homework, you upload it to the web, and then the teacher, the professor can see it, other students can see it just by sharing a URL. And so that way, it's just through a very simple, regular, structured process of just, here's my homework, here's my homework. So they just upload the Squeak to their Squeak assignments, homework, directly. So you can reach me here, and I'm hoping to get input from you folks about, is Smalltalk in the cloud important to you, and if so, what would it look like? Any questions?
I just tripped about this 6 cents a minute
Yes.
thing. That's quite expensive, isn't it? $85 a day, $2,500
No,
a month.
not minute, hour. Hour. Sorry, yes. Yes. It's not Yeah, I'm sorry, yes. I have misspoken.
It's a lot better. So that's
Yes.
about
$6 cents an hour.
$100 a month or something.
What?
$100 a month?
We can multiply it out.
Yes.
$1.40 a day, $43 a month. Which, you know, there are other services that will do 20 and 15 and 25 and 30.
A lot more reasonable.
And I am not advocating Amazon. I picked it for the same reason that people pick IBM. It's just, it's the biggest one out there. It's what lots of people are using, and I figured I'm going to try it out and see if I can make things work with it. There are plenty of others that we could look at. Yes?
About the image-based persistence.
Yes. Okay. Good, very good. It turns out that if we go look at one of these, so if we go to OptFaro, that's one part of it. I can't put my hand on it at the moment. One of the steps I have gone through in this process is creating a 500 meg virtual disk and attach it to the container. So each application runs in an isolated container and cannot see outside except for the things that have been explicitly imported. And one of the things I import is a read-write directory that's shared. And when I upload the Faro image, I copy it to that persistent directory. And so when you shut down the application, if you save your image, and I leave that to your responsibility, but if you save the image to whatever Smalltalk commands that requires, it will be on disk and I will keep that disk persistent.
I want to add that Amazon offers a free micro instance to everyone.
Yes.
For 1 year.
Amazon has a free micro instance. Instead of being 1.6 gig in space, which is the small, it is like 670 meg in RAM. I would like to try to get things going in that, and a few years ago, one of the early demos that I did and ran for quite a while was running Gemstone in a 256 meg machine with RAM. So I'm sure it can be done. I tried in preparation for this to run all of this, and processes got terminated for being out of memory. And so I don't think it's Smalltalk that's the culprit. I think that you know, I can run Gemstone in a small machine, but Cloud Foundry, the recommendation for Cloud Foundry is a medium. I'm doing it all in a small, but I think that I could get, I would like to get Faro and even Gemstone going in the free one, but such as it is, if you're not running it 24 hours a day, but just bringing it up and playing, I mean, even the work I've been doing where, you know, I've got 4 of them running right now, you know, it's a few dollars. So if you want to play with it, it shouldn't cost much. But the free one would be nice. Yes?
Yes, I've been experimenting with the database instances, the ones,
Yes.
the Oracle ones.
Uh-huh.
I managed to do this okay from VisualWorks.
Yes?
But it was much slower than the Postgres database I have on a Sliceville server somewhere.
Okay, yes.
So what is your experience with the speed? Is it better or is it?
I
was pretty bad. I was pretty.
well, I can tell you that, you know, as I said earlier, when I build the whole Cloud Foundry ecosystem and framework, it takes 80 minutes on a small, and 40 minutes on a medium. And I haven't compared that to other things. I've heard other people say, oh, you can do much better than Amazon. Again, I'm not advocating Amazon. I'm experimenting with the cloud, and I picked Amazon because it seemed safe.
What does Cloud Foundry bring you or give you?
Good, yes. Why am I going to all the trouble to use Cloud Foundry? And people have asked me that, both internally and externally. The thing that it gives me is, and I'm not sure it's worth the trouble, but what it gives me is the front-facing web server, the load balancing distribution. It gives me the tools for uploading applications. It gives me the tools, so from the client here, so here's where I did the push, CF logs, okay? I can just say, you know, so tell me what's happening up there on that machine. And it says, oh, well, you know, here are the environment variables that existed when we launched. Here's the, installation things. Here's standard error, here's standard out. And so if something crashed, there's tools to see what's going on. And so we did think, you know, and I have in the past been sort of building up from just taking a raw slice host or something and building it up. And years ago we had this virtual machine that we delivered and so on. Again, I'm not sure if it's the right answer, but I wanted to experiment coming at it from the other direction, where I don't have to build the web server, I don't have to build the tools for pushing the application up, I don't have to build the tools for seeing the health of it. Here I can, you know, just say CF apps. So here's a list of the apps. I've got, you know, I've got peer, it's running, you know, it would say crashed or down, or, you know, there's one that's taking up 256 meg, and here's the URL it's at. There's just a lot of infrastructure, and when it gets to something like the cloud, people are going to start asking about security. And as little as I know about this, I know even less about running a data center. And I don't think I'm going to take that on. Trying to get Smalltalk wedged into Cloud Foundry, that was an interesting project. But building something that's equivalent to Cloud Foundry, I don't have a reason to do that right now. Okay, well, we've kept you all. It's warm and our stomachs are growling. So let's go get some food. Thank you.